So now I'm going to introduce you to cylindrical coordinates. So the cylindrical coordinate system is just another way to describe 3 space. So this is going to be in 3 space, or maybe we'll say 3D or R3. Okay, so we're trying to describe things outside of the XY plane. We're going to give them that Z component as well. So I have a picture here that I got from this website. So I have the point, so the cylindrical coordinates, it's an ordered triple again, and the coordinates are R, theta, Z, in that order. Okay, so order matters, right? And it's the counterpart for our XYZ in rectangular, right? So XYZ in rectangular, R, theta, Z in cylindrical. Okay, so there's a picture here. So R is the distance out in the XY plane. Theta is the rotation from the positive x-axis. So R and theta are just the same R and theta from polar coordinates. And not only are they the same, but they have that same relationship that you remember from polar coordinates, right? So polar coordinates, 2 dimensions in the plane. Cylindrical coordinates are polar coordinates with a Z component. So the relationship between, right, R, theta, Z, X, Y, Z. So, right, X is R cos theta, same thing. Y, R sine theta. Same thing as polar, right? X squared plus y squared equals r squared, same as polar. And then Z is just Z, it's the same thing. So if you look at our picture, right, Z is the distance above the XY plane. Okay? And that's the same thing as it was in Cartesian, rectangular. Sorry, more things. Rectangular equals Cartesian. I will go back and forth. Okay, so I have one more picture here that really emphasizes that relationship. So, right, here's this point P up here in octant 1 where everybody's positive. It's just easier to see. Okay, so P can be described by X, Y, Z, right? You go out so far in the X direction, then turn to the Y direction and go so far out, and then straight up the Z. Right, that's one way you can describe to people how to get to this point out here in space. Or you could say, hey, from the origin, go ahead and walk R spaces out in a theta-like direction, right? That gets you to that same point here on the XY plane, and then go straight up. Okay? So those are just 2 different ways to describe how to get to this point out here in 3 space. All right, so let's practice converting. So once you get to Calc 4, then you'll be doing calculus. You'll be doing differentiating and integrating in these coordinate systems. For now, we're just kind of getting you used to them. Okay. So cylindrical coordinates. So these are in rectangular, so convert the following rectangular into cylindrical coordinates. So sometimes you're going to have to be told, hey, this is rectangular, or this is cylindrical, or you're going to have to somehow get it in context. So now we're told, so these are rectangular, and we need the cylindrical. Okay, so we need to convert these to R, theta, Z. Okay, so R, how would we get R? Right. So probably, right, X squared plus Y squared is R squared. Sorry, I keep moving my paper around here. So to figure out R, the square root of x squared plus y squared. So you can do that simplifying. R square root 2. What's theta? So now I'm just going to, well, the Z part, right? The Z part's easy. Right, so R theta Z, because the Z part between rectangular and cylindrical stays exactly the same. So the Z part is still going to be 3. So if I want to do the XY part, I can just think of XY plane, right? And I'm out 3 to the right, and I'm 3 up. So what angle is that? Well, if the X and the Y are the same, that makes it a pi fourths, right? So we're pi fourths when both x and y are positive. That puts us the pi fourths in quadrant 1. So that's just pi fourths. Okay. Let's see. So out 3 in the x, across 3 in the y, right? So we're here in this positive xy plane. Okay. And so that makes that theta the positive pi fourth version. And then r is 3 root 2. Okay, so let's do another one. So now we're negative x, positive y, positive z. Okay, so the z part we can just write down. That's a 5. R, we're going to square both of these. So 16 over 2 plus 16 over 2. All right. Square them, add them, root them. So that's going to be square root 16, aka 4. Okay, now let's think about theta. So I'm going to come here to our picture again. So now my x is negative, so I'm going to head back and then out in the positive y direction. Okay, so I have negative x. Oh, and look, they're both the same again. So now we're going to have a pi fourths again. I know I'm being easy on myself, huh? Okay, so negative x, positive y, that puts us up here in quadrant 2, right, when we're just looking down on the xy plane, because the xy plane is where we find our r and our theta. So I need the pi fourths from quadrant 2, so that's 4 pi fourths minus 1, so 3 pi fourths. Again, those both of these points describe the exact same place out in, right, 3 space. Okay, so now let's go the other way. So now these are cylindrical. So this is our theta z, and we need to go to rectangular, x, y, z. Parentheses, so we know their points. Okay, so the z stays the same. So 3 again for the first one. So now 5 is our r value. So we're going to go out 5 at an angle of pi thirds. Okay, where does that get us in terms of x and y? So pi thirds with a 5. So x is going to be 5 cos pi thirds. And you can go right to the relationship that we have up here. Right? X is r cos theta, y is r sine theta. I'm just doing the pictures just to help instill what we're talking about when we do that. Okay. So 5 cos pi thirds, so cosine of pi thirds, that's the 1/2, so that'll be 5/2 for my x. And then the y is going to be 5 sine pi thirds. Right, and so the sine of pi thirds is root 3 over 2, so that'll be 5 root 3 over 2. Okay. Same point. Okay, if you want to pause and try this next one on your own, I think it would be a good idea. Okay, so z stays the same. So then I have 8, right? X equals 8 cos pi halves. Right, cosine of pi halves, you're up at the top, that's a 0. And y is 8 sine pi halves. Sine pi halves is 1. So that's 8. So it's we don't go out in the x direction at all. So theta is pi halves, so we're going to swoop all the way over to here on the y-axis, go out 8, and then go up 13. Okay. So now let's describe the shape. So I have mostly equations and I have one inequality. So when I have this inequality, that means this is a solid. So the inequality means we're looking for a solid. So there's one thing. And the other thing is, so this is given in rectangular, right? Because I have x and y. There's no z. That means z takes on all values. So no z, pretend that says a z, means z takes on all values. Okay. So I have, right? X squared plus y squared. Let's think about equals 9. So that's a circle, radius 3, right? 3 out in the x, 3 out in the y. But then for z to take on all values, that means it's going to be a right cylinder with the z-axis as its central axis, right? So it's symmetric with respect to the z-axis. Okay, so this is the solid cylinder, radius 3, z-axis is the central axis. Okay. Oh, so that was actually in rectangular. I said it was going to be in cylindrical. It wasn't. Oh, how would I write that one in cylindrical? Let's do that. Since it is in rectangular and I meant it to be in cylindrical, how would I convert x squared plus y squared less than or equal to 9? How would I convert this rectangular equation or inequality into cylindrical? What does x squared plus y squared equal? Exactly. So in cylindrical, this would just be r squared is less than or equal to 9. Okay, so we could do that conversion as well. Okay, how about this next one? Theta equals pi sixths. What would that look like? I'm going to slide down so I can see my picture again. Right? So if I hold theta fixed at pi sixths, it doesn't have an r, right? My equation down here doesn't have an r and it doesn't have a z, which means it takes on all values of r. So after you swoop, right, pi 6, let's just pretend that's a pi 6 swoop, you're going to take on all the values along r and all the values along z. Okay, so you want to fill in, right, along that pi 6 rotation, all the different values of r, positive and negative, and all values of z, positive and negative. Can you kind of get that picture? Right, so that's going to be a plane. A plane that intersects, or that contains, how about this, that contains the z-axis. Right, so that plane's going to cut back through that z-axis. It'll intersect x and y just at that origin, but it'll intersect the z-axis all along. Okay. Oh, how about this one? So r equals 4 and z equals 1. What's being described there? Okay, so the r equals 4, right, tells us circle radius 4. But the other thing that we have is this z equals 1. So that means we're going to take this circle of radius 4 and just lift it up off of the xy plane. Circle radius 4 up 1 from the xy plane. Okay. How about this one though? Just r equals 4. So r equals 4, I'm just talking about, so no theta, no z, which means, right, we use all values. Remember x, y, z to follow the right-hand rule. You could label them differently, but just make sure you're following the right-hand rule. X cross y, thumb points to z. So r equals 4, so we're going to draw that circle. Oh, my circles, gosh darn it. There's a circle with r equals 4. Okay, so take on all the theta values, so swoop all the way around. And no z, so that means we're going to go right up and down. So this is just going to be that shell. So this is going to be the cylindrical, and I mean shell, just the outside, right, set of points, not filled in. Inequality means it's filled in. Okay, so I have a cylinder here. I'm not sure it's going to work. here, let me put it directly over the top. And so here's my glass cylinder. I'll put it down there so that corner can be at my origin. It's just an Old Spice jar that I had to empty it out so I could use it. So if I start sneezing, it used to have black pepper in it. Okay? So you can see, right, we could go X out to the side, Y up top here. Okay? So I could swing out. So if I wanted to describe a point up here on my cylinder, right, I could describe it by coming out to R, right, out R and theta. So R comes from the center out to that point. Theta is that rotation. And then comes straight up as far as you need to go, or down, right, if your Z was negative. Okay, so that is real brief cylindrical coordinates.